Previously, we discussed proportional quantities. Proportional quantities have a relationship that stays the same as each quantity changes. For example, suppose a certain candy contains 230 calories in a 2.8 ounce serving. In this story, the ratio of calories to ounces of candy was 230 calories to 2.8 ounces. And because of the way candy and containing calories works, we know that this stays the same as the number of ounces of candy that we eat changes. So far, we've just referred to these quantities as the first quantity and the second quantity. Shortly, however, we're going to want to distinguish between the ways that we approach the quantities involved in a problem like this. We're going to want to think about which quantity is independent and which quantity is dependent. What does this mean? In an application, the independent quantity is one whose value we can control or at least easily measure. The dependent quantity, then, is the one whose value we wish to predict based on the value of the independent quantity. Okay, how does this work in practice? Let's say we have this situation. Let's say a certain candy contains 230 calories in a 2.8 ounce serving, like we did a moment ago. We have several other sizes of packages of the same candy, and we want to predict their calorie content. In this situation, the other size packages of candy, what we know is how much they have in them, and what we want to predict is their calorie content. So we tend to say that the independent quantity is the amount of candy, and the dependent quantity is the number of calories. When we write ratios, we prefer to write the independent quantity in the denominator. Now, it isn't wrong to set up a ratio the other way, but it looks a little bit weird. So in this problem, describing the ratio as 230 calories for every 2.8 ounces is better than describing the ratio as 2.8 ounces for every 230 calories. Let me give you a story and ask you to identify the independent and the dependent quantity. Suppose a certain business has decided that it must employ 2 custodians for every 75 offices. If they're opening a new facility and need to decide how many custodians to hire, what would be the independent quantity, what would be the dependent quantity, and what would be the usual way to write this ratio? Pause the video and try this now. Okay, well, if they're looking at a new building, they're going to count the offices and figure out how many custodians they need to keep that many offices clean. So the independent quantity, the one that's easy to choose or measure, is the number of offices. The quantity that we're hoping to predict is the number of custodians. And so the usual way to write the ratio is dependent over independent. So number of custodians over number of offices. And according to the story, it's 2 custodians for every 75 offices.